A. Chemistry, functional groups we did the other day, and today, 8.3. Branches, which honestly are pretty much exactly what they sound like. And pretty much exactly like they sound like. Branches are groups of hydrocarbons. We're just talking about carbon and hydrogen, C's and H's, and they're placed on longer changes. They branch off, kind of like a tree branch. I kind of ran out of room there and got sloppy. Sorry about that. So when you're naming them, branches end with YL. So that's how you identify that you're working with a branch, or if you're doing the naming, look for that Y or add that YL to say that you have a branch. When we write out the words, we put it in front of the parent chain, which make a lot more sense here in just a minute when I show you guys an example. Ready for that example? I'll tell you something with 4 carbons here. Now you can kind of see the branch. The branch is off. Kind of makes sense why it's named a branch. Let's go ahead and add all of our hydrogens then. All right, and for the sake of terminology, this is what we call the parent chain. So you got to find the longest continuous chain. That's the parent chain. And here is the branch. Go ahead and count up my carbons here in the parent chain. So 4 carbons. Again, I like to go both ways, right to left and left to right. That way it allows me to see the lowest number a lot easier, I think. All right, now let's name this guy. Okay, so looking at the branch, we'll start with him. How many carbons in the branch? Just 1. So hopefully we were all pretty comfortable with what one carbon is. And if not, guys, that should be a clue. Hey, if you don't know, if you're sitting there like, I can't remember what. Hey, we've done enough of this now. We should know that meth is one carbon. Here's the new part. YL. That tells us we're working with a branch with one carbon in it. Methyl. The parent chain is 4 carbons. Again, we should all know 4 carbon prefix by this point. Go back, look those up if you haven't. You should know those. Bute is 4 carbons, all single bonds, ANE. Methylbutane. And then just like we did for functional groups and double bonds, we have to say where that branch is at. It's on the 2nd carbon. And if I went with the red, if I went left to right, I'd say 3, but 2 is better than 3. 2 is lower than 3. 2-methylbutane. It is all one word, methylbutane. And that's how we write it. Questions? Cool. Let's do another example, huh? So we've got 6 carbons. No, 2 go up.
I'm trying to confuse on the number thing. So it's number. Like how.
Okay. So for people at home, the question is, why did we go with 2 instead of 3? So our rule is, in organic chemistry, we always have to get the lowest possible number. There is no rule that it has to be left to right or right to left. That doesn't matter. The idea with organic chemistry is we're writing these on paper. It's a flat piece of paper. It's not a word. It's not a sentence. It's really a 3-dimensional object, kind of like this pen. This pen is the same, whether it's like this or like this. It's still the same thing, right? And so that's kind of the idea with organic chemistry is it doesn't matter if it goes left to right or right to left. So when we number it, I always just like to, just go ahead and get it out of the way at the beginning, number it in both directions. And then whenever you find, your branch in this case, or if you had a double bond or a functional group, you always got to make sure you have the lowest possible numbering scheme. So if I had gone left to right, I would call it 3-methylbutane. Coming back right to left, it's 2-methylbutane. 2 is lower than 3, so we go with 2. So the rule is lowest number, left to right, right to left. That doesn't matter. In fact, I'm going to throw something on top of that here in another example or two. All right, back to this one. Let's make sure we got all of our hydrogens. And always make sure every carbon makes 4 bonds. At the end of those bonds, put those hydrogens. Sometimes they start to kind of run into each other. It happens. It's all right. Just do your best to get them all in there. And I like to number it both ways. Sometimes you see it right off the bat, which way you should go, left to right or right to left. I like to number it both ways, just to be sure. So 6 carbons. Six carbons. Okay, so our parent chain has 6 carbons in it. Here's our branch coming off the top there, 2 carbons. And we'll start with that guy. Hopefully we're all pretty familiar with F as our 2 carbon prefix. It's a branch, so we add YL, ethyl. Then we move on to the parent chain, 6 carbons. Hex is 6 carbons. A and E, they're all they're all single bonds. And then finally, where is the ethyl? And if we go with the red numbering, it'd be on the 4th carbon. If it went with the green numbering, it'd be on the 3rd carbon. 3 is better than 4, so 3-ethylhexane. Think you got the hang of it? Ready for a curveball? Nope. We're actually on the page here. Anybody feeling adventurous today? Want to take a stab at this one?
Would the parent chain be the longer one?
Always. Parent chain has to be the longest one. Nobody at home wants to chat at me? Possible answers? Very close. Very, very close. Almost. Almost. So both of you guys have the same mistake here. So people at home, we've got a couple of guesses for 4-butyl octane, which is very, very impressively close. Yeah, the mistake was they were saying butyl octane. It should be propyl octane, but they caught the trick, which is impressive. Usually people don't catch the trick right away. So again, the rule is you have to go with the longest continuous chain as your parent chain. Just like we were talking a second ago or a minute ago. It doesn't matter if it's left to right, right to left, or up and down. It's all the same. Well, it's weird for us to think of like writing words vertically, but this isn't a word. It's a 3-dimensional object. We're drawing more than we are writing. So this one goes up and down. 1, 2, 3, 4, 5, 6, 7, 8. So there's our parent chain up and down, 8. Can I go back the other way just to make sure we don't have a lower numbering scheme that way? And here is the branch. There's the branch. So we go ahead and we name this. And again, you guys were super, super close. Propyl is 3 carbons. You guys were just calling it bute. That was the only big mistake there. So propyl for 3 carbons. YL tells us it's in a branch. Our parent chain has 8 carbons in it. Prefix for that one. Hopefully everybody knew that one before they even started class. Oct for 8. So octane for the parent chain. And then finally, what carbon is it on? Well, if we go with green, it'd be 5. If we go with red, it's 4. 4 is lower, so 4 propyl octane. Nice work, guys. Everybody okay with me flipping? Got a couple more things to show you. Oh, wrong way. All right, there we go. First of all, let's make sure we get this rule down so we all see the rule and know the rule. Here's the rule. You always have to identify the longest continuous chain and make that your parent chain. The reason why that's kind of a tricky rule The reason why it's kind of a tricky rule is because there's no rule that says it has to be straight. We just saw one that wasn't horizontal, it's vertical, or it doesn't even have to be straight. It's going to drive some of you guys nuts. Sorry. With a grain of salt, it's a goofy year. Let's just have fun with it. Or if you make mistakes, grain of salt, wash it away, laugh at it, and be like, oh, cool, that's what I did wrong. That's the attitude we got to have this year. So if this is fun for you, awesome. If this is frustrating for you, sorry. Let's take a look at one of the most missed questions on a test. We're not testing, but in a typical year, this is one of the most missed questions on the test. So everybody sees the branch. Any thoughts? People at home. I've had lots of people in class participate today. Anybody at home want to take a swing at this one? No one feeling particularly of interest today? Can you get some chat at me? Think you got it? Ooh, excellent. Had a very, very good guess. Couple of really good guesses. Okay, so had a guess just now for two ethylpentane. And the reason why we had that guess, 2-ethylpentane, so we see the chain, 5 carbons, with an ethyl coming off the second. That's the most common answer I get on a test. Unfortunately, it's not right. That one we did on the last page, that was a curveball. This one is a knuckleball in the dirt. Ah, and sorry if you don't like this stuff. Got to think outside the box sometimes. The longest continuous chain does not have to be straight. We have a chain with 6 carbons in it. 6 carbons is longer than 5. So guess what? That's our parent chain. This is the branch. Which makes this (3-methylhexane). Meth tells us 1 carbon, it's a branch, YL. Hexane tells us the parent chain has 6 carbons in it. That branch is on the 3rd carbon. So again, the rule is always identify the longest continuous chain as your parent chain. The tricky part is it's not always a straight chain. So sometimes you just got to kind of take a step back, look at it from outside the box. If you're not a fan of that type of stuff, it gives you headaches, you don't like it, sorry. Hopefully you guys enjoy a challenge, okay? It makes it kind of fun. All right, let's do another one. Let's see how you guys do with this one. You see it? Any thoughts on this one? Chelsea? Nice. Yep. Guys, you could have named this last week. You guys could have named, there are no branches on this one. It's just one continuous chain. 7 carbons. Heptane. Heptane. Fun stuff, huh? Hang in there. Hang in there. Even if you make a mistake here and there, this is just a year to have fun with it. You guys keep trying. I will be there about that. One more thing to show you. Kind of a weird looking structure, but it's super, super common in chemistry. So we got to know how to name it because you're going to see it a lot. Here is the basics of it. We have a ring, a hexagonal ring of carbons with 3 double bonds, alternating double bonds. Again, we got to make sure every carbon has 4 bonds. They each currently have 3, so they all get 1 hydrogen. I'm not going to give one to the guy on bottom, though. So I'm actually going to attach him to a chain. That's how we usually see him, is attached to something. So this guy I'm going to attach to a chain. Just make that chain 3 carbons long. So again, weird structure. And this is what it really looks like. Real life, that's what it is. Carbon double bonded to carbon, single bond, double bond to carbon, single bond. But to make matters even weirder, here's how you're often going to see it. Same exact thing, just kind of a chemist's shorthand. This is how chemists draw this. It's the same structure, same thing. It's just shorthand, and then they add it to the chain, kind of like what we just did. And again, you just got to kind of be familiar that when you see this weird shape, this hexagon, and these bonds here, these represent the double bonds, 3 of them, just like there's 3 over here. This is that. And to make it just a little bit weirder, you'll also sometimes see it written like this, which is the same exact thing. A circle inside of a hexagon is the same thing as that, which both of them are this right here, really. But you're probably almost never going to see it written like that. Chemists like to take the shorthand approach, and that's one of these 2. If you're wondering why it's a circle, it's a really good question. You should probably take organic chemistry next year. I'm not really going to get into it in this class. All right, so all 3 of these things are the same exact structure, same thing. You probably see one of these 2, and they are this. All right, these guys are called, they have a special name because they're incredibly common in chemistry. These are called phenols. These are called phenols. And hopefully you're starting to speak the language a little bit. You're recognizing that YL is telling us it's a branch. So you see it branching off. So we go to name this. The structure that we have is called phenol. 3 carbons is our parent chain, so phenyl propane. One last step, what carbon is it on? For all of them, it's on the 2nd carbon, so 2-phenylpropane. Crazy stuff, huh? Caden, do you have a question for me to go?
Yeah, why is the 3 carbons that mentioned nothing?
That's a really, really good question. And depending on what book you look at, you could argue that this is the parent chain and that this is the branch. But for us, we're going to keep it simple and just call the propane the parent chain. That's a really good question. You could go either way on it. You take an organic chemistry test in college and call this the parent chain since it's longer, and call this the branch and name it that way. But I don't want to get into how to name this and then call this one a branch. So we're just going to call this branch. But awesome. Good question. Excellent question. Down here? So the phenyl could be on the 1st carbon, right? I could have put on the very 1st carbon and then it'd be 1-phenylpropane, but it's on the 2nd carbon. So I'm telling my readers, hey, I've got a propane, and on the 2nd carbon is a phenyl group. Oh, kind of what Caden was asking. Yeah, you could make that argument, but it's a lot more difficult to name if you say that this is the parent chain. So we're just going to call a phenyl a branch, and suffice to say that that's what we're going to do it. It's easier that way. Great questions, guys. I love it. Others,